So you see, now I show you this one, how to integrate this. Okay, if let's say I give you something like this, same, you see this one same, but here got x minus 2. This is easier if you compare with this. Why? Because you see I can write like this, then this one is negative half, then I try to integrate the negative half, it will become half over half, isn't it? But I have to differentiate this. This is a must. You have to when you differentiate this, you will get 4 minus 2x, or is 2 minus x, yes or no, or is negative 2x minus 2. So what I mean here, you can just add a negative 2 here, am I right? You can just add a negative 2, so you divide by negative 2, that's why you get this. Then this is correct. Of course this one after that you simplify lah, this is correct. Okay, next one, if let's say I give you something like this, okay, if I give you something like this, this one no square root sign, that means you can factorize like this. So you can factorize, once you can factorize, you can use partial fraction, you get this, then you can integrate this, you can integrate this. So to integrate this ln x, to integrate this, here you must have negative 1 over negative 1, that's why this one become negative 1 over 4, then this negative 1 will become ln. Okay, that's all. But now how to differentiate, how to integrate this one, as I said just now. Okay, of course you cannot do like this. Let's say this is 4x minus x squared negative half dx, yes or no? So if you want to integrate this one, yes, you will get 4x minus x squared half divided by half. This is definitely correct, but the problem is what must we have here? We must have 4 minus 2x, because differentiate this, so once you add this, you have to divide back, yes or no? So this is 1 over 4x minus 2 must be there, correct? Because you differentiate this, you get 4 minus 2x, so you have to divide by, sorry, this is 4 minus 2x, 4 minus 2x, 4 minus 2x. So this part is correct, but this part is wrong. Okay, so you cannot. So once you cannot, then you try to use partial fraction. Can you factorize this one? Cannot. So you cannot factorize. What you have to do, of course, substitution. I also don't know what to substitute. Cannot. Then here, what are we going to do? We are going to do completing the square. So you do completing. I'm going to do the completing the square. Why? Because you see, when I do the completing of square, I will get this. Then this one, it will be very familiar already. You have this one and square root minus and the square here, so this one can become arcsine. But to become arcsine, this one must be 1. That's why the 4 you have to take out. The 4 take out is half. Is 2, half. This 2 is half. So this is divided by 4. But you must change into a bracket. So the bracket is like that. X minus 2 square like that. Yes or no? So you see, here, if you want to what we call integrate by memorizing the things, this one, when you differentiate this one, you get half, isn't it? Because the inside the bracket is half x minus 1, so you differentiate is half. So because you differentiate this one is half, you must have a half here. So here you must have 1 over half, isn't it? 1 over half. So when you simplify this one, you get 1, and then therefore this one with the square root sign, the 1 minus and square, you get arcsine. Then x minus 2 or 2 plus c. So this is the answer. And this one from here to here, this is memorized. Okay, that means you skip certain step to show how you get from here to here. Then okay, you see, I show you half 1 like that. So you just substitute this one as sine theta, because I know this is arcsine, so I sine theta. So I substitute as sine theta equal to x minus 2 over 2 like that. then I differentiate the sine theta, I get cos theta d theta, and then here I differentiate, I get half. Okay, this is half x minus 1, so I get half dx. So the dx will be 2, bring up like that. Then I substitute 1 over 1 square root 1 minus this is sine theta, so sine square theta, then 2 cos theta d theta, I substitute, and this actually is cos theta, isn't it? That's why this one can be cancelled, and the 2 and the half also can cancel. Therefore, you get d theta like that. So you get theta plus c, and then you know that from here sine theta is this one, the theta is arcsine of this. So is it you get the same answer? Exactly the same. Okay, so next time you see this, even though the square root, the square root sign with the square like that, don't be panic. Use partial, completing the square to make it arcsine. Okay, I show you another example. Look at this one. Look at this one. Because I want to integrate this. Of course, you see, this is proper fraction. If I want to integrate like that, you see cannot, plus 10 negative 1 dx. You integrate the negative 1, you will get ln. Okay, then x squared plus 2x plus 10, and then plus c. But you integrate this, you get ln. But another condition is here you must have 2x plus 2. So 1 over 2x plus 2. 1 over 2x plus 2. So this part is correct, but this part is wrong. Because the x is outside already, so it's wrong. So what we do, this method cannot, we try to factorize. Can you factorize? I don't think so. You can factorize? Cannot. So if you cannot factorize, what you do? Completing the square. So I do completing the square. You see how I do the completing of square? I complete this one, then I get this. After that, this is 9 plus. Then you see now no square root is 9 plus square. This is arctangent. So the 9 take out like that. Okay. Then after that, you see if you want to use the faster method to skip, okay, you differentiate this, you get 1/3. Isn't it? Because this is 1 over 3x plus 1 over 3. Differentiate, you get 1/3. Then 1 over 1/3. Then you get 1/3. Then this one becomes arctangent. Okay, that's the answer. Okay, so if you want to show the step, you continue from here. Okay, I continue from here. What I do here, I substitute this one to be tangent theta. So you can go through tangent theta, I get secant square theta, differentiate, then I get this. Then after that, I substitute. Then this is, you see, tangent theta is this one, I differentiate, I get only this one, you go through. Then this is 1 plus tangent square theta. Then I substitute here, I can cancel a lot of things, I can cancel, then I get this. Okay? Now we look at the next one, the last one. So after I do all this, you can do until page 5. I think it should be question 78. Page 5. Then 6 and 7 you don't do yet because I still got some small things to tell you, okay, regarding trigonometry. Okay, state the constant a and b such that x minus a is this one. Hence hence you are asked to integrate this. So hence mean after you must make use of this. Okay. So how to find the a and b is just like partial fraction. We have done this. How to find a and b? You can substitute x equal to -2. Then you can substitute x equal to 0. Then you see, I show you. Substitute x equal to -2. Then you get b is -3. Then substitute x equal to 0. Then you find what is your a. Then this one can be written like this. So because hence mean you must make use of this. So you see x minus 1 can be written like this. So I just follow like that. So when I want to integrate, I break this one into 2. Okay, I separate them. So here, when I want to integrate, this one can be integrated. Why? Because this one can be written x plus 2. Okay, then this is 5 minus 4x minus x squared. This is -half. So you want to integrate the -half, it will become half divided by half. But the problem is, in front here, we must have what? We must have differentiate this. You must have -4 minus 2x, isn't it? So the -2 you take out, you get 2 plus x. That's why they get you 2 plus x here. That's why you must add a -2. So 1 over -2. So with this 1 over -2, then this is correct. So you can cancel this one, you get this. Okay, for this part. Okay, how about this part now? How about this part? This part, you must use completing the square. So you see I'm using the completing of square, then I get this. Then you see this one with the square root sign minus square, this is arc sign. I'm going to use arc sign. Then you see I take out this one, I get this. Okay, now I show you the step. So I let sine theta to be this one, then I get this, everything. Then after that, okay, this part already completed. So the 3 you cancel, and then here I substitute, and then I also substitute the dx, I get this. Finally I get only 3 theta. Then after that I substitute. That's all. So you can do until question 78 on page 5.